Okay, let's continue our discussion for Module 2. So we are now on bearing capacity of shallow foundations on a slope. So previously we discussed for a shallow foundation that is constructed on top of the slope. Now this is a foundation that is constructed on the slope. So this is an illustration for the foundation that is constructed on a slope. So basically for this, if you're going to compute for the ultimate bearing capacity, you are given with this expression for purely cohesive soil and for granular soil. So this is the figure showing the nature of plastic zone under a rough continuous foundation on the face of a slope. So we are also given with a chart, variations of the values for ends of CQS with respect to beta, and you have to identify your beta and of course the range of the value for your stability number, and you have to identify the ratio between this of F all over B. This one, you have to identify the value for the beta, for the angle beta, and for the angle of friction, and also the ratio between the F all over B. And then you could identify the value for your n sub CQS and n sub gamma QS. This is for n sub CQS, and this is for n sub gamma QS. So after that, we have our last topic, which is the uplift capacity of foundations. So of course, we know that uplift forces occur. We know that foundations are subjected to uplift forces or uplift pressure. So when does uplift forces develop? Of course, it occurs and it can be developed because of hydrostatic pressure, the seismic activity, or overturning moments. When the structure undergoes overturning, one end is subjected to compression and the other is tension. So for this one, we are trying to have we're going to compute for the ultimate bearing capacity for foundations that is subjected to uplift forces or uplift capacity. So for foundations that is constructed in granular soil, of course, our cohesion is equal to 0. So we have here an illustration for a shallow continuous foundation that is subjected to uplift forces. And of course, you have the parameters present, and of course, you have the forces. It is you have the presence of the passive force acting on our shallow continuous foundation. So for this one, the ultimate load can be expressed in the form of non-dimensional breakout factor denoted by F sub Q, and this is the formula. And of course, for the breakout factor, it is a function of the soil friction angle and the ratio between the depth of embedment and the width of the foundation. So we have to take note for a given soil friction angle, the breakout factor increases with the ratio between depth of embedment over the width of the foundation to a maximum at this of F all over this of B, which is equal to the critical value of this of F all over B, and it remains constant thereafter. So for foundation subjected to uplift forces, this of F all over B should be less than or equal to dF over B critical. It is considered as shallow foundation. Otherwise, if our ratio of the depth of embedment over the width of the foundation is greater than the critical value of the ratio between the depth of embedment over the width of the foundation, it is referred to as deep foundation. So we have here formulas that was provided by Mayer and Adams in the computation for the to estimate the ultimate uplifting load. So we are given with the breakout factor for shallow circular foundation and for rectangular shallow rectangular foundation. So we are also provided with the values for the computation for the critical ratio between the depth of embedment and the width of the foundation for rectangular foundation. So for this one, we have a step on how to estimate the uplift capacity of shallow foundation that is constructed in a granular soil. So we have here the steps. And if we are having foundations in cohesive soil where phi prime is equal to 0, you are given with this expression to compute for the ultimate uplift capacity Qs of U. That is, the foundation is in a purely cohesive soil. So of course, you have the area of the foundation and range shear strength of soil, and you have your breakout factor, F sub Q. And we have, it was thus in 1978 also reported some model tests result with square and rectangular foundation. So based on those results, he has this equation that the critical value of the ratio between the depth of embedment and the width of the foundation for square foundation, this expression should be less than or equal to 7. Of course, this is the critical embedment ratio of square or circular foundation. You have the undrained cohesion C sub U. So it was also thus observed that the critical value of the ratio between the depth of embedment over the width of the foundation for rectangular foundation, you have this equation, and it should be less than or equal to 155 of the ratio between the depth of embedment over the width of the foundation for the square foundation. So based on the findings of thus, proposed an empirical procedure to obtain the breakout factor for shallow and deep foundation. So according to his procedure, the alpha prime and beta prime are two-dimensional factors that is defined by this expression. So yeah, F sub C is the breakout factor for deep rectangular foundation. So we have here a step procedure to estimate the ultimate uplift capacity for foundation on a cohesive soil. So we are given also with the formula to compute for the breakout factor for a deep rectangular foundation. And of course, to compute for the ultimate uplift capacity, this is the equations. This is the equation. And this equation is applicable if the ratio dF all over B is greater than the critical value of dF all over B. However, if the dF all over B is less than or equal to the critical of dF all over B, you make use of this equation. So for this, you have an example. Consider a circular foundation in sand. Given for the foundation, you are given with the parameters, and they are going to calculate the ultimate bearing capacity. So for this one, we have to identify the value for our ratio between dF all over B and the critical value between dF all over B, so that you could identify if this is shallow or deep foundation. So for this one, since dF all over B is smaller than the critical value of dF all over B, this is considered a shallow foundation. So we have to compute for the breakout factor for a circular foundation that is constructed in sand. So we have to, using this equation, you have to identify our M, and using a table and substitute, you're given with 2.638. Once you have identified your breakout factor, you can compute now for the ultimate bearing capacity, substitute to our equation, and the resultant is 121.7 kilonewton. The second example is a rectangular foundation in saturated clay. It measures 1.5 by 3 meters. You are given with the parameters. You have to estimate the ultimate uplift capacity. So for this one, you have to identify also whether that is a deep or shallow foundation. So you have to solve for the ratio between dF all over B and dF all over B critical. So for this one, we have computed that our value is based on our computation, we have identified that our dF all over B for this rectangular foundation its critical value for DF all over B is 8.89, and the actual DF all over B is 1.2. So this is less than, DF all over B is less than the critical value of DF all over B. So this is considered or identified as shallow foundation. So for this one, since this is a foundation constructed on a saturated clay, you have to know the value of alpha prime and your beta prime. Then once you have identified the value for alpha prime and beta prime, you can use the formula to compute now for the ultimate uplift capacity. Substitute the given values, the given data, so we come up with 540.6 kilonewtons. So this is the value now for our ultimate capacity for a rectangular foundation in a saturated clay. So that ends our discussion for ultimate bearing capacity for shallow foundation special cases. So I just hope you have now a knowledge on the computation for shallow foundation, considering a homogeneous type of a soil and non-homogeneous type of a soil. You have to take note that there are different considerations in the computation of shallow foundation dependent on the nature of the soil. So if the soil is if the soil is horizontal, it is homogeneous, you make use of the parameters, the formulas, the conditions based on the first discussion of shallow foundation. However, if that is non-homogeneous and there are layers, there are slope, so you refer to the conditions to compute for to solve for the certain problem given a certain condition, and could identify what formula that you're going to use so that you can compute for the ultimate bearing capacity. So thank you.